Hello and welcome to this PowerLink Connect installation and setup tutorial. Today we'll be going through the steps to get you up and running with your very own PowerLink Connect project. Firstly, let's quickly review the installation steps from the PowerLink Connect Quick Start Guide. These steps need to be completed before attempting this tutorial. Once you have completed the installation process, you should be able to open the PowerLink Connect sample system from the desktop icon. From the menu, you can select the Data Summary List or Real-Time Data List. The Data Summary List is very useful as it allows you to control your entire substation from one interface. Note that I can click on a row or a point in this list and control that point directly from the data summary list. Our objective in this tutorial is to start your new PowerLink Connect project and get you to the point where you also have a working data summary list and graphical objects within your project. So let's go ahead and start up your new project. All of your project data is stored in the Prophecy Simplicity project folder. You can see the directory location for that here. We can see that there are multiple demonstration project files available. The SIP Power demo is the sample system project that we have just been looking at. It is configured with test devices connected to a simulated driver in order to mimic an actual substation. The PowerLink template project is pre-configured to run the DMP driver and mower manager on its startup. It includes the PowerLink base classes, but it has no database. Therefore, it's the perfect starting point for your own PowerLink project. Mower Manager is a background PowerLink Connect application that connects to Simplicity to retrieve data and facilitate device control. Let's take a copy of the PowerLink template project folder so that we still have the original as a backup, and we will rename that copy to something that is appropriate for you. For the purposes of this tutorial, we're going to call our new project My PowerLink. Now we can open the project in Simplicity Workbench. We need to make sure that we have closed the sample project that we had running earlier. There should be no other projects running when you try to start up your new My PowerLink project. Once the My PowerLink project is running in Simplicity Workbench, we can change the name of the project to match the folder name. So now we need to set the default project. We need to let Mower Manager know which Simplicity project it is supposed to connect to, as this runs as a separate process to Simplicity. This is done in the iPower INI file, which can be found in the Prophecy Simplicity data folder. Here's the location for that directory. If you had multiple projects that you would like Mower Manager to connect to, you would list them all in this project list, but we're really only interested in the new My PowerLink project, so I'll delete the others. So the next step is we will start the project. We can now open Simplicity Workbench and then open the My PowerLink project and start the project. This initializes applications like Mower Manager and starts the project using the default security settings. So now that we have our new project running, we need to customize the security passwords for the new project. We'll start by configuring the iPower service user in Simplicity. Mower Manager uses this account to authenticate with Simplicity and collect data such as alarms and events. Here we're going to change the password to something that makes sense for you. I'm going to use the name PowerLink in all capitals. Now that we've done that, we still need to configure Moa Manager to know the iPower service user. To achieve that, we right-click on the PowerLink icon in the system tray of the taskbar and click Configure. Note that this icon will only appear if the My PowerLink project is already running. We choose the My PowerLink project, change the connection projects, and set the username as iPower Service and the password as PowerLink. So now that that's done, that's all the configuration that we need to do in Simplicity at this stage. So now that we have created and defined a new project to build on, the next step in the process is to configure DNP devices and database points. We can do this by opening the DNP Configuration Manager within Simplicity Workbench. Here we can configure DNP channels and devices and then link the two together. Let's start by creating a channel. So we can right click and select Add Channel. Right now I'm connected to a test SCADA network with a DNP simulator running in the background. Firstly, we're going to add the channel that has been configured from the DNP driver. In this case, it will be from the DNP simulator, which we're going to call Test Channel. You should be using the IP addresses of your actual master and slave devices. The master port should be set to port 0, which will mean it will be the first available port, while the slave port should be using the default port 20,000. So we configure the channel settings name as Test Channel. We configure the master DNP address as 1. We leave the remaining defaults. We go to the IP settings. The DNP slave address will be 127.0.0.1, port 20,000, and the DNP master address will be 127.0.0.1, and the port is 0. Now we will add the device. This will connect over the IP connection that we just set up in the channel configuration. We should give the device a descriptive name, and for the sake of consistency we should give it a name similar to the channel. I'll use the name Test Device. In this dialog you can specify the polling intervals for different classes of data. I'll leave mine with the default, but yours will depend on the system data requirements and network design. Click OK to finish the device configuration. Now we are able to connect the device to the channel. We can do this by right-clicking on the device and selecting Connect to Channel. In this dialog, we select the slave address. Mine is set up in the test harness as 100. In the Channel Properties section, we will select the channel that we set up a few steps back. The rest of the settings will be dependent on your network design, so I'll leave them as the defaults in this case. Now we can enable the channel and device using the enable checkboxes for each. We can see that the driver will start communicating with our device through the Message Logs tab. We can now save and close our DNP client and move on to putting points into our database. So at this part of the tutorial, we'll show you how to create a digital switch, which consists of a multi-bit status point, a few analog currents, and open and close controls. In Simplicity Workbench, we select Objects, you right-click on it, and you'll be taken to the New Object dialog. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we enter an appropriate name for the device. In the Object ID field, we For this object, I will follow the default PowerLink naming convention which we've used for the sample system. This is a 5-part naming convention defining the service, the location, the device, the type, and the descriptor. You can set a different naming convention depending on your system data requirements. This could be using 3 components or 4 if you like, but the default PowerLink template convention is in 5 parts. Establishing a naming convention can provide advantages when designing your database, so that all the PowerLink features are available to you. Importantly, PowerLink uses this naming convention to sort and filter data for quick and simple display to system operators. The service I will use for my test switch is POW, referring to a power service. The location of this switch will be a substation on Smith Road, so I will use SMT to indicate that. The device will be called CB1 or Circuit Breaker 1. The type is a multi-bit input, so I will use MB. And finally, the descriptor will be STS, as we are reading the open and close status of the switch with this device. For the class ID use, we're going to use a digital read-write switch. This is a pre-configured PowerLink class that can be viewed in the classes section in the workbench. We click OK and we are presented with a dialog to configure the device. A lot of the settings will depend on your system, like the alarming and the change approval. I'll leave some of mine as the default, but I'm going to change the device ID to sample DMP. The input address is the multi-bit address you should be reading from the RTU to return the status of the switch. The same with the control address. The input address name will follow the same format. We're going to enter testdevice.1.1.0 and testdevice.1.1.1 and check the bit 1 input exists. Because we're setting up a controllable switch, we should provide control addresses. The format for this is the device name that we configured earlier in the DMP client, followed by the specific RTU control address. The control output will depend on the value expected by the field device. I'll leave mine as the default, 1 on both controls. The display tab allows us to label the state of the device. Normally a switch follows the default transit, open, closed, faulty states as shown, but your device may vary. Similarly to the controllable switch, I now wish to add 3 analog currents to be displayed next to the breaker. I'll do this the same way as I've added the controllable switch. I go to Objects, right-click, New, and type in an object ID that follows the same naming convention we explained earlier. I'm going to use POW, SMT, CB1, AI, AMPS A. AI stands for Analog Input. The class ID for the analog input in PowerLink Connect is Analog Read Only. Again, I go through the Object Properties dialog and fill in the relevant data. The device ID is sample DMP. The resource ID is PTM FR. We choose the alarm class high. The input address for this will be the test device 0.30.1.0. We enable the high alarm and the high alarm, and we'll enter some sample limits: 220 for the high limit and 150 for the alarm high limit. We also enter a description, in this case CB1 A phase amps, and the EU label will be A. Now, because we're dealing with 3-phase amps, we can use the class that we've just created by using duplicate to create the B and C phase amps. So I'll go through that process now. I'll make the new object the exact same naming convention, but with this one will be amps B. Click OK. Right click on that new object for amps B, and we'll go into the object properties, change the address, which we increase the address 1 point, and we'll change the description under display to CB1 B phase amps. Apply that, and that's just a quick way of duplicating the first amps A, and now we'll do the same again to create amps C. So we'll duplicate amps B, create a new destination object, this time CB1 underscore AI amps B, amps C. OK, and we'll right click on that one, or double click on that one to get the properties dialog. Go to the address. This one will become test device 30.1.2, and we'll change the description to CB1 C phase amps and apply that. And now that we've defined the 3 different phase amps, we can stop and restart the project. So now we're going to move on to the last phase of this tutorial, where we create a screen object for the new device. Now that we have the switch and the analog objects created, we're able to create a new screen to display them on. To do this, we will use the iPower default picture, as this has already been set up with scripts needed to run PowerLink features. We navigate to Screens and find the iPower default picture.sim. Right click on that to edit it. We go to the top of the menu of the screen and select Drawing. Under the Illustration section, you'll see that we can draw a class object button. We click it, and now you have the class drop a cursor. We click anywhere on the blank screen to create a new object. In the dialog that's opened, we select the class ID that we wish to place. In our case, this is the digital read-write switch. We click Browse, and all of the digital read-write objects in the project are displayed. We could add an additional filter in the object ID field if we had multiple objects and we didn't want to display all of them. So we click on our Power SMT Circuit Breaker 1 multi-bit STS object, and we click OK in place to place it on the screen. We are now presented with a dialog box where we can enter our analog points. In this video, PowerLink Connect uses the point naming convention Power SMT CB1 to find appropriate analog points to automatically fill these fields. We make sure that our currents A, B and C are selected in the drop-down boxes, and we click OK. We should now save the screen, saving it as test.sim. And then close. And we can then open it in our runtime view. To do this, we go to Screens, Press F5 to refresh so that our newly created screen will be added, and we look for an open test.sim. So now we're in the final phase of our tutorial. We're going to review that our new object is working and the real-time data list is populating. So now you can see that we've successfully added a digital controllable switch with 3 analog currents, and we can see that their corresponding current values are simultaneously updating. The changing current values can also be viewed through graphical trends. To access this, we click on Analog Value, and in the PowerLink dialog that will be displayed, we go to the Details tab and click on the Trends button. We can also see that our newly created digital controllable switch can be viewed and accessed through the data summary list or the real-time data list. So you can see that we now have a new project working in a similar fashion to the original sample system we showed you at the start of this tutorial. So this concludes the PowerLink Connect installation and setup video. Thank you very much for watching,